Hello and welcome to the course of HDL Digital Circuit Design. Today's topic is Verilog code for 1011 sequence detector that is using Mealy overlap way. Myself Shilpa Rudrawar, Assistant Professor School of ENTC Engineering, MIT Academy of Engineering, Anandi, Pune. So moving towards today's topic. So in previous sessions, we have seen what is meant by Mealy or Moore FSM, how to go ahead with the state diagram of sequence detector. We have seen that in Mealy FSM, output as well as next state depends upon present state and input. And in Moore FSM, output and next state depends upon present state only. So output is state dependent. So for that video, you can see the description box where I will be sharing the link of previous video. So you are able to see that is the sequence detector 1011 which is having clock, reset and input IP, that is the inputs, and OP is the output. And we have seen how input has been given, that is string of 01, sequence of 01 is given, and from that I need to detect 1011 sequence. How many times it is getting detected? That is whenever it is 1, output is 1, meaning of that your sequence is detected. That way you are able to see 1, 2, 3, 3 times 1 means 3 times your sequence has been detected from this. So now there are two ways, overlap and non-overlapping. We are considering here overlapping way. So for that video, just go through the description box. Now this is the state diagram. As we are going ahead with the Verilog code for sequence detector, here you should be knowing the state diagram for that, which is explained in the previous video. Link is provided in the description box. So moving ahead with how to write a code for sequence detector using Verilog. So this also we have seen in the previous video. Now this is the code for 11 Mealy sequence detector, that is overlapping type. Now, as you know, in Verilog, everything you need to write inside module and end module. So this is what is the module which is started. Now, we have given the name as a FSM 1011. You can give any name, but we have given FSM finite state machine, and this is detecting a sequence of 1011. So at first glance only you will be understanding this is the code for 1011. That's why that is given in that way. Now, what are the inputs? So I have told you that is reset, clock, input, temp and OP. These are the input and outputs. Now, why we have taken this temp, I will be explaining afterward. Now, out of this, which are the input and output that is mentioned over here? So, inputs are clock, reset and IP, and output we have considered it as a range, which is OP, that is output, and this is the temporary register we have taken to update our output. Now, here, as you know, this is the state diagram and this is A, B, C, D. These are the states, and this is not mentioned in the input because you know here this is the block diagram where I am having clock, reset, input and OP, where we have not defined anything related to the state A, B, C, D, as well as this transition from C to D or B itself or A itself from A to B, that is not mentioned. And that's why you need to consider a user defined data type, that is parameter over here. Now, why we have taken this as a range and 1 is to 0? Because here these are how many states you are having, that is A, B, C, D, these are the 4 state, and if you need to define that using 0 and 1, so you require 2 bits, that is 0 0 0 1 1 0 1 1, and that's why 2 bit are defined using this range 1 colon 0, that is 2 bit, that is current state and next state. Why we have taken these two things? That is, if I am in on A state, I'll be moving to B state, so B state will be my present state. Now same way, if I am in A state, my next state will be B. So that's why I need to consider this current state as well as next state. And that's why range has been defined, because it should be holding the data. So this data type every time you need to define as a range. Now, as I told you, this is not mentioned in the block diagram where input and outputs are mentioned. So for that user defined data type, that is parameter you need to use. That is, if you are having toy car and you want to move it forward, reverse, left, right, so that particular part you'll be defining using parameter. So you'll be writing parameter left, right, likewise. So here we have decided or defined state A, B, C, D over here. That is user defined data type. So parameter you need to write A. If you have given S0, you can write S0. Here I have given name to state as A. That's why it is mentioned as A. Equal to 2-bit binary number 00, because this A state is defined by 00, because if I need to denote it by 01 in binary, so I need to define it using 2 bits, and that's why A equal to 2-bit tick, that is binary event, binary number 00. Same way 01, 10 and 11, meaning of that A is defined using 00, B using 01, C using 10 and D using 11. Now this is same for whatever sequence detector you are doing, you are implementing. This will be same, just minor changes will be here depending upon how many states you are having, and over here rest will be same. Now as we are implementing that using behavioral modeling style, and we are using case statement as well as if-else statement. So in behavioral modeling style, as you know, whatever the statement you are writing inside always at, it should be a sequential statement, that is if else, for, while, case, this type of statement you can use. Now here we have written always at, because this is a behavioral modeling style. Now my dependency will be on clock. So if positive edge of clock is coming, I'll be checking reset. If reset is active high over here, the circuit will be resetted, else it will be performing normal operation of sequence detector. So this is active high reset. What is the meaning of active high reset? As we have written if reset, meaning of that if reset is 1, what will be happening? That system will be resetting. Means for reset equal to 1, system is getting resetted, and else, that is reset equal to 0, your system will be working as a sequence detector, and that's why this is active high reset. Now what should be happening whenever the circuit is resetted? It should be in A state. So that's why it has been written always at passage clock. It has to check positive edge of clock, and after that if reset is 1, then A will be your current state. Now what is written? What is the meaning of current state equal to A? That you will be in A state. So my current state, next state will be different thing, current state will be same, other thing. So if the circuit is resetted, my current state will be A, and that's why A will be assigned to current state. Else, now if reset is 0, means system will be performing its normal operation. So what will be happening? Else, what it will be doing, that next state will be my current state. Now what is the meaning of that? If this is moving from A, you'll be moving to B. At that moment what will be happening, that B will be your current state now, and from B you will be moving to C, or you will moving to B only. So that way you need to think, and that's why next state will become your current state, and that's why this has been written. So at positive edge of clock, your state will be assigned to the current state, next state will be assigned to your current state. So for this, definitely you need to see previous video how this state diagram has been drawn, what is the meaning of this transition, what is the meaning of these circles, everything is mentioned in clear way, in the simplest way in that video. Now over here op equal to temp, now we have written op equal to temp. What is the meaning of that? Now this temp we have assigned inside this, you are able to see temp is assigned, that is 0. So why it is 0, that I will be explaining, but this is assigned, and this value is getting updated to the op in this loop, in this always block. So although it is becoming 0 inside this, temp is becoming 0 inside this, but it is updating its output. This temp value will be given to the op when this particular clock positive edge is coming. So this is very important. Without this it is not working properly, we have tried so much, so you need to do like that. Now why this begin and end is written? So whenever there are more than one statement inside your if, you need to write begin and end. Suppose here instead of this one statement there might have been two or more than one statement, then you need to here also write begin. So where to write begin? That over here after reset, or you can over here you can start with the begin, and after this two statement, one more statement suppose that is there, after that you will be writing end. So until and unless there are one statement inside your if else, there is no need to write begin and end. But if there are more than one statement inside your if else, so you need to write begin and end. Hope that part is clear. So here because of one statement we have not written begin and end, but here in else part you are having two statements, that's why we have written begin and end. Hope this part is clear. Now what is the meaning of this end? That always you have start started, that is begin, and that's why you are ending this with end. Now this is one procedure block, always block we have written. We need to write such two. So this is first where my next state will be assigned to current state as well as the resetting state will be there. So this will be happening at the positive edge of clock. Now in the second always block, what will be writing? As you know, in Mealy, my next state as well as output depends upon present state as well as input, and that's why over here present state means here it is mentioned as a current state or IP. So my next state depends upon current state as well as IP, that is input. So that's why inside this particular always as a sensitivity list we have written current state or IP, and here it is mentioned as a clock passage clock. So that particular thing you need to keep in mind. Now begin, you need to start the begin of always, and that's why we have started with the begin. Now temp is equal to 0. Now over here, as I told you, x by y, that is input by output, or x by z input, IP by OP. So that way input by output you are writing, and that will be one only at the last state, because you are only when sequence is getting detected, whole sequence is getting detected, your output will be 1. And that's why here for most of the cases up to C, your output will be 1, and that's why temp equal to 0 is mentioned by default. Okay, in another way you can write it inside this loop also, but it is mentioned over here because every time it is 0, only at the last state from D to B it is making output 1, and that's why temp 0 we have done. So this is what is the dummy variable we have taken, that is temp, and it will be updating inside this your output. So temp will be assigned to OP, that is to output, after means within this particular loop, and that's why this is temp equal to 0 we have mentioned. Now we are implementing that using case statements. So case, how many cases are there? That is when you are in A state, whenever you are in B state, C state, D state, that way you need to write that 4 times. So A, B, C, D. So case, it depends upon what current state. I am in A state, B state, C state, D state, that is I am in which state, that is current state is what. So this is written as a current state. A, B. Again over here we have written C and D. Now again same particular part is I have printed twice to avoid the confusion. So same part is repeated, and to avoid confusion I have given this line number also, so don't get confused over here. So always we have written this. So if you are in A state, what is the meaning of that? If I am in A state, meaning of that, if input is 0, it will be in the self loop and output will be 0. And if input is 1, then it will be moving from A to B and output will be 0. So if you are knowing this diagram, then and only then you will be able to write it. So what is written? If A. So A, begin. Now as there are more than two one statement inside this case, and that's why it is started with the begin and end. If there is only one statement inside your case, so no need to write begin and end. So as more than one statement, you need to start with begin and end. Inside that we are using if, because if 1, if 0, input is 0, if input is 1, that's why if IP, meaning of that if input is 1, so it will be moving from A to B, and that's why next state will be B. That way it is written. Else it will be having self loop, it will be on A only, and that's why it is written as a end. Inside this, if you want to write output as a 0 every time for input is 0, likewise input is 0, output is 0, input is 1, output is 1, so you can write after by entering over here. So press enter and write this statement, that is temp equal to 0 here, again temp equal to 0 here. But whenever you are writing here temp equal to 0 or here temp equal to 0, then inside if you are having more than one statement, again you need to write begin and end, again you need to write begin and end. So hope that part is clear. I have cleared that in previous slides only. So again you are in B. If input is 1, it will be on the self loop, so input will be 1. Input is 1, it will be on self loop. So here's one mistake is there. So what you need to do, you need to write B here. And if next state, it will be moving to C, means if input is 0, it will be on C. So make the changes, instead of A you need to write B here. Okay, if I am in B state, so it will be moving to B if input is 1. So input is 1, it will be on B, else it will be on C. Same way, if you are on C state, what will be happening? If input is 1, it will be moving to D. So it is mentioned D. And if 0, it will be moving to A state, reset state, end. Again, now you are in D state. So in D state, what is happening? If input is 0, it will be moving on C state. So if input is 0, so here it is 0, else condition is here. So it will be moving on C state. If input is 1, it will be moving on B state. So you have written B state. Now why this begin is written? The same thing as we have written temp equal to 1, because at this moment your sequence is getting detected, and that's why 1 by 1 input is 1, output is also 1, and that's why inside this if there are more than one statement, this also, and that's why you need to write begin and end. So 1 is written, else everywhere output is 0. That's why we have not written it separately inside this. If we have written here at once. But here your output is changing, and that's why inside this D state we need to write temp as a 1. End, this is the end of what? Your this begin. Then end case, because you have started with the case, and that's why you need to write end case. What is the end means? Over here you are started with the always loop, that is begin, and that is the end of this, and end module, that you have started a module and that is the end of that module. So your whole Verilog code is written inside module and end module. So hope this part is clear, and this way only you need to write properly that this is the end of this. So that's why this is coming exactly below this. This is the case. So it will be coming exactly like this over here. Then end, you have to start with this, then end will be over here. So as this is not below to this, that's why you are not able to see that exactly below to this. But that way you need to write it. So hope this part is clear. Now same way, suppose some different sequence is there that you require 5 state, then one state will be added over here. So depending upon state diagram, you have to change this. Everything will be same, step wise, that will be same. So hope you understood the code, Verilog code for 1011 sequence detector. So moving towards the test bench. Now how to write a test bench? So what is the meaning of test bench? Test bench is nothing but providing input to the circuit under test or unit under test. So stimulus you need to provide. Now what kind of stimulus you are having or inputs you are having? So we have seen over here we are having clock as a one input, reset as a another input, and IP as a third input. So these three inputs we need to provide using test bench, because at this moment hardware is not created, that's why you can't give 1 0, that is VCC and ground. So you are testing that your design, and that's why you need to give soft inputs. So that soft input you need to generate, and that generation is possible using test bench. So for that only you are generating a test bench for providing soft input or stimulus for your design. Now over here we have written module, the name is given, you can give any name. Range, that is RST, clock in IP, these are what input you need to generate, that you need to define as a range, and rest of the thing you can define as a wire, that is output, whatever are there in the code that can be defined as a wire. So OP and temp, these two are the output, and that's why they have mentioned as a wire. Now this particular test bench you are writing for UUT, which is named as FSM 1011. So in previous slides we have seen this is the name given, that is FSM 10_1011, and the same name you need to give over here, otherwise it will be getting linked with the another one. If that particular code is not available, then it will be showing you a question mark. Okay, so that's why this FSM_1011 UUT, this is what is compulsory to link your test bench with the UUT. Okay, so this is a important instantiation. So reset of your test bench is connected to reset of your UUT, that is code. Clock of test bench is connected to clock of your UUT, that is design, whatever the code you have written. Again input with input, temp with temp, and OP with OP. So that way dot means that particular part is connected to this. So test bench, it is generating certain inputs that you need to apply to the UUT, that is design, whatever you have written over there, and that's why this is what is the syntax you need to follow, and this is the comma. It is given as a separated by comma. Now, what you need to generate? You need to generate first reset, clock, and then IP. That is input. So clock, how to generate? In the various videos we have gone through, you have gone through now. So I have told you the way to generate a clock. So that's why that many things you need to generate parallelly. That many initial block you can write, because whatever initial blocks are there, if I have written 1, 2, 3 initial block, all will be executing parallelly, concurrently, but whatever written inside that will be executing sequentially. So that is very important, and you need to remember this. So I have written 3 initial blocks, meaning of that I'll be generating 3 different inputs parallelly. So over here, you are able to see this is what is the reset, this is what is the clock. These are generating at the same time. Whenever reset is 1 at this particular point, clock is 1, and IP is also 1. So at the same time, all are 1. So all these things are starting at the same point, but internally it is executing sequentially, one after another, one after another, one after another. So this is what I just want to tell you. So clock is 1. At the start you need to consider clock as 1 or 0, so we have considered 1. Forever, meaning of that I want to generate a clock continuously, and that's why forever is been written. Hash 10, that is the time scale, and clock equal to not of clock, this is the negation sign. So previously it was 1, after 10 time scale it will be 0. That way every 10 time scale it will be changing from 1 to 0, 0 to 1, 1 to 0, 0 to 1, and end. So this will be repeating forever, so continuously it will get generated. Now second initial begin we have written for the reset. So reset, this circuit is active high reset. When the reset is 1, your circuit is getting resetted, and when reset is 0, your circuit will be performing its own operation, that is sequence detection. And that's why for a reset equal to 1, we have written for small amount of time, that is 20 time scale, and reset equal to 0 we have written for the higher amount of time, because we need to perform our task of sequence detector. So you can change this value as per your requirement, and this is the begin, that's why end. So now clock is generated, reset is generated. Now you need to apply input. Now what kind of input and how you need to apply the input, this is very very important. Just concentrate on this particular part. So we have written again initial, and again we have written begin, then there is a end, and end module, that is module started. Now how we have written, as we need to detect sequence 1011, so in this particular part 1011 sequence should be present, so that it should be detected. Okay, and that's why we have written IP equal to 1. Now how to give this? So IP equal to 1, because I want to detect 1011 sequence. Okay, so 1 has been given over here. Now hash 40, that 40 time scale has been given. You can get hash 20. Now every time hash 20 is given. Why? Because your this clock is of 10 time scale, and whenever a clock is repeating, means clock cycle of your clock over there is 10 plus 10. It will be 1 for 10 time scale, and it will be 0 for 10 time scale, and that is the cycle, one cycle. So one cycle is of 20 time scale, and your input should be same for that clock cycle, because we have written positive edge of clock. What is meaning of positive edge of clock? At the positive edge only it will be detecting your input. In between that, if your input is changing, meaning of that, this is what is the positive edge of clock. This is positive edge, and this is one cycle. This is again positive edge, this is second cycle. So your input should not be changing in between this clock. Why? Because if it is changing, it is now changing from this to this, and in between that again it changed from this to this, low to high. What will be happening? It will be detecting your input only at the positive edge of clock. At the second change, it will not be detecting. Although you are able to see it is getting changed, but it is not getting detected, because it will be detected only at the positive edge clock. So at this moment only it will be detecting the change, and now it is 1. So it will not be detecting any change in between the clock. So for that reason, you need to apply your input in such a way that it should not be changing in between clock. So that's why every time you need to give a time delay of 20 time scale, because here clock cycle is of 20. 10 plus 10, 20. And that's why this is mandatory to give your inputs for that particular time period. जितना clock है उतना ही आपको देना है in that way. Okay, so over here IP equal to 1. We have given time of 40, 20 plus 20. So 2 times it will be 1, 1. So here you are able to see For one clock cycle, it is 1. Again, for one next clock cycle, it is 1. So for two clock cycle, your input is 1 that way. Now, what you have to give? Again, IP is 0 for 20. Again, it is 1 for 20. Again, it is 1 for 20. So it is the string of 0, 1 you are giving for particular uh, sequence detector. Okay, so time delay, I told you how to give it. So now you are able to see over here, this is what 1011, one sequence is getting detected. If overlap 1011, second sequence is getting detected. Again 1010, this is not a sequence. So 1011, this is third time sequence is getting detected. So you need to give this string of 01 in such a way that some sequence should be getting it should be getting detected. Okay, so that way you need to give. So that way you can give multiple inputs over there. I have given this much. You can try different input also. So end and end model. So hope this particular part of test bench is clear. Now here you are able to see that reset is 1, so it will be reset state, that output will be 0. It is not defined, actually we have not defined. When reset is there, output is what, that we have not defined. We have just defined that state is A, and that's why here undefined, that is red means undefined, it is coming. If you are writing something over here, that current state is A, and after that if you are writing temp equal to 0, so that way it will be showing you a 0 output, but at this moment nothing has been mentioned, and that's why you are able to see this red color. So this should be clear. Now when reset is 0 and clock is positive edge, means your circuit will be starting, that sequence detector is working over there, and that's why positive edge of clock, it has detected 1, this input is 1. Again next clock positive edge, it has been detected 0. Next clock pulse, it has been detected 1. Again for the next clock pulse, it has been detected 1. So 1011, and that's why this will be on D state. If you are able to see, understand that state diagram, it will be on D state, and on D state if input is 1, it will be detecting a sequence. So it will be high for one clock cycle. Again, this is 1, this is 0, again 1, again 1. At again this positive edge clock pulse, this will be on. That is one time sequence is detected, second time sequence is detected. Now this is 1010, sequence is not detected. 1011, so this is what, here the sequence is getting detected. So third time your sequence has been detected. So in this way you will be getting a waveform, and you need to understand why we are getting this 1 at this moment, because sequence is getting detected at this particular point, because this is 1011. Okay, so hope this part is clear. This is the lengthy video, but definitely you understood how to write a Verilog code for sequence detector, what is the test bench, how to write it, and how to see the simulation waveform. So thank you everyone. Thank you for the patience listening. Happy learning.